So this is another example of a multiplication by 2 where you have a 0 and 1, and in output you will get carry bit and 1 bit. Yeah. Similarly, this is a not CC and get. So this is control not get. So you have a target and there are two control B and C. And then you take a combination using the same rule. Target should be reverse. So you will get the input and then corresponding output you can see in a form of A prime, B prime and C prime. So these are the some sort of a what is called the gates in optical computer. So only small modification you should do. Because every new thing has certain rules, right? And we have to follow the same rule. This is a okay. So I'll move. Yeah. So what we are talking about, this thing, one person was asking me. So this basically the integer key basically lies between n square and 2n square. So you have a peak around 256, but as per the rule, input register must contain this is q minus 1, what I told. So it becomes 255, 256 minus 1. Similarly, if you have 15, it will become 16, it will become what is called 15. So this is the basically the algorithm, and this algorithm is known as SOR algorithm. So SOR algorithm is a part of a quantum computer where the mathematics are, you can say, the bit calculation is done following a simple thumb rule. So anyhow, so SOR algorithm can further be modified in terms of a 0, 1, 2, 3, 7, a mod 15, again output register is 1. So these are the different part of a what is called transformation from input register to the output in terms of 7 raised to power mod 15. So this is a mathematics. This is between 0 to 7. So you can see 0, 1, 2, 3, 4, 5, 6, 7. Okay, and then this is the mode. Well, I will tell you the application in a more detail when let me show you. So is it all? Okay, so I think finally we reached to the last part of the lecture. Maybe you have taken a tea. So many new things. You are not asking questions. That is quite surprising. So in 2007, qubit machine wire filter and the SOR algorithm what I shown you, it is successfully a factor of 15. Then now lot of new developments are coming up. Lot of research is going on. People are publishing papers. One person is also well known, maybe you are knowing or not. He is also member of the Nobel Committee, Professor Gachibowli. He is a old professor of our university. So because of his contribution and all, he is now shifted to Oklahoma after his retirement. So first he became a director of ERL, Physical Research Laboratory. Then he became a CSI director, and now because he worked with a Nobel laureate, and he is a pioneer in the world, not in the country. So he started this calculations first time in that. And all his paper you will find PRL and PRL. He write in PRL paper. So all theoretical calculation he was carrying out, and the experiment was demonstrated by the Americans. When he was in India, he was doing calculation on the paper, and experiment was done there. So that was the here when we were a student, we used to see his mathematical skill, how he is doing in 0 and 1. But later on we realized how genius he was. So he was actually a student of Professor Wolf. He got a Nobel Prize in optics. So Wolf himself told that he is one of the best student of my PhD student. So whenever I was invited on one program in his honor at IIT Delhi, so people were telling in US when he go from here to there, he asked professor, asked all his students that you ready with your problems because the GS is coming and he will solve your problem. So he is now there, he now become a bit old also, but his contribution now I remember that how this quantum computing is grown up. So you know this is a science where reason is that quantum mechanics is not properly taught, or it is taught then it is basically restricted to the only classroom. Because very few scholars you will find, and those are doing optics, they are not doing experiment, quantum. So I am one of the fortunate person that I joined the group of these colleagues. So J. Agarwal and Professor Tiwari and Professor Datta Gupta, these are the three pioneer people in the country, and they were in SU. So when I was like a scholar like you, I used to think I should also get the opportunity to work with them. And really when you think and you do, you may get a chance. So then ultimately I got selected and we started designing a new system that is also based on that, but it is more further modified of a technology. So all this, quantum computer things, calculations, they are in existence and coming are appearing in a different manner. So this is a one, what is called aspect which I mentioned. Thank you very much. Your essence, I know because many things you are not very much familiar, so I try to elaborate. But still, if you have a question, I will try to address. I will try to give the answer. Yeah, you ask physics, that will be better. Yeah. No question? They are very kind people. Really kind. Kind people never ask questions.